Both temperature and pressure affect solubility. This may be something that you would know from your experiences. For example, if you want something to dissolve more, you would use hot water. Well, here's the general effects. When we're talking about solids, so in general, the solubility, which remember is the amount that will dissolve in a given amount of solvent, will increase as you increase temperature. So for solids, it will go up with temperature, the solubility. Now pressure also can affect solubility, but not really for solids, because solids are not that influenced by pressure. So there is not an effect from pressure. So temperature increases it, pressure has no effect. I'll just put an X. Now gases, on the other hand, are affected by both temperature and pressure. In general, the amount of gas that can be dissolved will decrease as you increase the temperature. So solubility goes down as you increase with an increase in temperature. So for solids, the solubility goes up as you increase the temperature. For gases, the solubility goes down. Now pressure, if you increase the pressure of the gas over the liquid, that will also increase its solubility. So if you wanted to dissolve more carbon dioxide into a solution, if you increase the pressure of the carbon dioxide above the solution, that would cause an increase in solubility. So solubility will increase if the gas above it has an increase in pressure. Now, in a previous video, we talked about supersaturated solutions, which are above the solubility limit. Now, the thing about these, though, not only are they above the limit, but they all the solute remains dissolved. Supersaturated takes advantage that the solubility limit changes with the temperature. So you trick the solution. And so what you do is you heat up the solution, which raises the solubility limit, because the solubility of a solid will increase as you increase the temperature. Then you slowly cool it back down, and if you slowly cool it, all of the solid gets tricked into remaining dissolved. So you really have a solution that has more solute than it should, but it all remains dissolved. Now these systems are not very stable, and so they oftentimes will very easily come out of a supersaturated state and go right back into saturated, where the solid precipitates to the bottom. So let's look at a question and try to put these effects into a different thought process. So it says, predict the effect of each change has on the solubility, and there's two things here. So this is sodium carbonate, and this is a solid. So this is a solid. And then the second one is nitrogen, and you see here it has a G, which means it's a gas. So for letter A, if we increase the temperature, so for number 1, the solid, if we increase the temperature, we increase the solubility. For number 2, a gas, if you increase the temperature, you decrease the solubility. So decreasing the temperature. For number 1, a solid, the temperature and the solubility and the temperature do the same thing. So if we decrease the temperature, we will decrease the amount that dissolves, so we decrease the solubility. For a gas, however, if you cool it down, the lower temperature will have a greater solubility. That's one explanation as to why a soda will go flat faster in a warm temperature, because as the temperature rises, the solubility of the carbon dioxide in the soda decreases. Now pressure. So on number 1, on both of these having to do with pressure, the changes in pressure will have no effect on the solubility of a solid. However, for a gas, if I increase the pressure of nitrogen above the sample that it's dissolved in, that will increase the solubility. And if I decrease the pressure, it will decrease it. So the pressure changes only affect gases, not solids.